In this video, we're going to be learning about the different properties of matter that exist, which are simply characteristics that allow us to describe specific behaviors of substances when we observe them in different ways. We're going to start by looking at a type of properties that we call physical properties, the opposite of which being chemical properties that we'll look at later. Now, a physical property is any characteristic that a substance has that can be observed without changing what that substance is when we do the test. One easy example of a physical property that is very easy to test is the concept of hardness. Now, to be able to test hardness, all you need is a substance and something that you can hit that substance hard with, like, for example, a hammer. Because hardness, when we test that, all that we're testing is how easily breakable that substance is. Now, if you recognize this substance as being a diamond and this substance as being chalk, it's very obvious which of these substances is harder than the other. So we know that a diamond is going to have a very high hardness because it's difficult, if not impossible, to break a diamond. The only substance that you can hit a diamond with and get it to break is another diamond, whereas chalk is very, very easy to hit and grind up into this powder, so we say that it has a very low hardness. Now, the reason why hardness is a physical property is no matter how hard we hit a diamond or chalk, hitting it and breaking it into smaller pieces does not change what the identity of this substance is. Chalk is still chalk, whether it exists as a big block like this or as a powder. It has the same chemical structure. Another example of a physical property that's closely related to hardness is the concept of malleability. Now, if this word is unfamiliar, we can do what we normally do with unfamiliar words and break it into different parts. The root word of malleability is actually a Latin word pronounced malleus, and malleus is the Latin word for hammer. So that tells us that malleability measures how well a substance reacts to being hammered, specifically how easy it is to bend a substance while hammering it without breaking whatever that substance is. And here we see a big difference between metallic substances and non-metallic substances. So metals are said to have a very high malleability because they don't break. Instead, they can get flattened and even shaped into different shapes because of their high malleability. And this is why blacksmiths use metals as the material for swords and other types of weapons, whereas non-metals, such as this red powder here, have a very low malleability because they shatter and break apart into powder and cannot be shaped. So with both hardness and malleability, we are looking at qualitative properties of matter because we can't exactly put a number to these physical properties like this. But when we look at the next two physical properties, that being what we call boiling point and the closely related melting point, we can see that these are quantitative properties because we can specifically measure these. Now, most people understand that when you boil water, you are turning water from a liquid into a gas by increasing the temperature. And we know that water turns from a liquid to a gas at 100 degrees Celsius. So boiling point is something that we can measure very easily, hence why this is a quantitative property of matter. So if we want a more general definition, boiling point and melting point measure the temperature and pressure at which we can change the state of matter of a particular substance. And melting point is the same idea, only we're turning it from a solid into a liquid, and the temperature, 0 degrees Celsius, is different than the boiling point. Now, in the previous video, we looked at the differences between solutions and mechanical mixtures, and this is actually investigating another physical property that we call solubility. And we can see in the word solubility, you can kind of see that this looks similar to the word dissolve. So solubility is a measurement of how well one substance, usually a liquid, is able to dissolve another substance, again, usually a solid. For example, if we take a look at this white powder, we could say that this white powder is either salt or perhaps sugar, and we know that if you mix a small amount of these into a larger amount of water, eventually, even if you get some salt or sugar piling up at the bottom, if you shake the water enough, eventually these are going to dissolve and disappear into the water. For that, we say that these are soluble. And if you mix two substances that are soluble together, we get a solution, as we talked about in the previous video. However, if you do this with oil and water, for example, no matter how much you shake the oil and water, you will not get the two to mix and form a solution. So we say that oil is insoluble in water, and we know that two substances that are insoluble that give us two distinct layers are what we call a mechanical mixture. Let's just write that carefully. So once again, this is an example of a physical property, because even though you're mixing two substances together, the fact that you're mixing salt and sugar and water together doesn't change that you have salt, sugar, and water. We aren't creating something new, and likewise, we aren't changing oil or water by putting them together, hence why these are still physical properties. However, when we look at chemical properties, we see that chemical properties measure how well two substances are going to react together in order to give us something that is entirely new. So chemical properties, unlike physical properties, always measure or always describe how multiple substances interact with each other and how they can give us something new that did not exist before. Probably the easiest chemical property to measure is something that we call combustibility, which is a very fancy word for how well something is to catch fire and burn. Now, for anybody that's tried starting a fire before, which is probably all of you, you understand that in order to start a fire, you need oxygen. If you don't do this outside where there's a lot of oxygen, the fire is relatively difficult to start. Therefore, combustibility is a description of how well a substance is able to react with oxygen in order to start a fire. Now, with metals, we can look at how well they react with oxygen by looking at a characteristic that we call oxidizability. That's a very long word. How many syllables is that? Oxidizability. I think that's a 7-syllable word there. But oxidizability is similar to combustibility because it's also looking for how well a substance reacts with oxygen, although usually oxidizability is talking about metals. So when metals react with oxygen, they change color when they undergo a process called rusting, like this. And this is important because scientists that work with metals are always looking for ways to stop rusting from happening to make metals last longer. Finally, we have a characteristic that we call pH that you will study in more detail in Science 10 and if you study chemistry in grade 11 or 12. pH measures how well specific substances react when we put them into water. Now, if you've ever had vinegar on food or if you've ever drank lemon juice, you'll recognize that both of these chemicals are very, very sour because when they put them into water, they react as acids, and the fact that they are sour is your way to be able to tell because they react with water in a very specific way. If, however, you've ever gotten soap in your mouth or drank baking soda in water, you'll recognize that these taste very bitter because they react with water a different way, so we say that they are bases. So pH, measuring how well something reacts as an acid or a base in water, is another example of a chemical property. In the next video, we're going to look at different ways that you can identify that a chemical reaction has taken place and therefore focus on chemical properties in more detail. Until then, try the practice problems below and see if you can use your knowledge of what a physical and chemical property is to identify which is which in the table below.